Hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate in the Materials Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. I also got my Bachelor's of Science at this institution as well in the Pharmaceutical Chemistry program. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or tutoring, then check out the links in the description below. So now I'm just going to get started on our set of questions in today's session. All right, so question number 1 asks, what is the molecular weight of water? Okay, so as we all know, water has chemical formula H2O. So there are 2 hydrogens and 1 oxygen. If we wanted to calculate the molecular weight of water, it's going to be 2 times the molecular weight of hydrogen plus the molecular weight of oxygen. So these values can be found on your periodic table. In the case of hydrogen, its atomic mass is 1.01 grams per mole. And in the case of oxygen, its molar mass is 15.99 grams per mole. So now let's just add these values up, and we end up with a total molar mass of 18.02 grams per mole. Okay, so let's see what our junior tutor said. They said the molecular weight of water is the sum of the atomic weights or atomic mass in AMU of all the atoms of hydrogen and oxygen in water. The atomic masses of hydrogen and oxygen are 1.008 and 15.99 AMU. Solution is shown below. Okay, so they show that you need to multiply the atomic mass of hydrogen by 2 and by 1 for oxygen, and you end up with 18.015 AMU. So this solution is correct. Okay, so now moving on to question number 2. So question 2 simply asks, what is the molar mass of magnesium? So again, you can look this value straight up on the periodic table, and you'll find that the molar mass of magnesium is just 24.31 grams per mole. So let's see what our junior tutor said. Molar mass is the mass in grams or kilograms of 1 mole of a unit, example, atom or molecule of a substance. This is determined experimentally. For magnesium, we can consult the periodic table, which gives us the molar mass to be 24.305 grams per mole. Okay, so this solution is correct. Okay, so on to question number 3. What are some examples of oxidation numbers? So first, I'm going to start off by writing down the definition of what an oxidation number is. So basically, the oxidation number is the charge that atom would have if the compound that it's in was composed of ions. Okay, so I'm going to write down 2 examples. Let me make it a different color. So I'm gonna write down 2 examples, but before I answer them, I'll go over what the junior tutor said, because it might help us answer this question. Okay, so I have 2 examples. The first is aluminum sulfate, and the second is just hydrogen phosphate. Okay, so first I'm just going to read a few of the rules that'll help us calculate the oxidation number. So over here, the junior tutor has helpfully wrote down all of the different rules. The first one is that the oxidation number of a free element is always 0. So what they mean by a free element is that if it's in its solid form or its gas form and it's just something you find in nature and not a part of a compound, then its oxidation number will always be 0. Rule number 2, the oxidation number of a monoatomic ion equals the charge of the ion. Okay, so that makes sense. The oxidation number of hydrogen is +1, but it is -1 when combined with less electronegative elements. So basically when it is a hydride. Oxidation number of oxygen in compounds is usually -2, but it is -1 in peroxides. Rule 5, the oxidation number of a group 1 element in a compound is +1. Similarly, the oxidation number of a group 2 element in a compound is +2. The oxidation number of a group 17 element in a binary compound is -1. The sum of the oxidation numbers of all of the atoms in a neutral compound is 0. And finally, the sum of the oxidation numbers in a polyatomic ion is equal to the charge of the ion. Okay, so those are all helpful rules. So now this brings me back to our examples I have here. So I'm going to try and find the oxidation number of the atoms that are underlined in green. So in the first example, I'm going to write out an expression that will help us try to calculate the oxidation number. So on the left of the equal sign, I'm going to put a 0, which shows us the charge of the compound. So since this is a neutral compound, I'm going to write 0 on this side. And then I'm going to show how many of each ion there are. How many of each ions there are. So there are 2 aluminums, 3 sulfurs, and altogether 12 oxygens. Okay, so if we remember our rules, each oxygen atom has a -2 charge. And in the case of aluminum, it's not in the rules, but it has a +3 charge because it is in group 3 of the periodic table. So these are the 2 oxidation numbers that we know. And now that I know these oxidation numbers, I can plug them into our expression. So 2 times plus 3. I'll just write that. So now all I have to do is solve for the oxidation number of sulfur. I can do that just by using basic math. Okay, so I have calculated the oxidation number of sulfur to be plus 6. Okay, so let's try to do the same thing for the next example. Okay, so there should be H2PO4 minus. So since this ion has a minus charge, I'm going to put -1 on the left side of the equation. I'm then going to show there are 2 hydrogens and 1 phosphorus. And there's 4 oxygens. Okay, so again, from our rules, we know that oxygen has a -2 charge when it's not a peroxide. And we know that hydrogen usually has a +1 charge if it is not, yeah. So now I can plug it into our expression. And we are going to solve for phosphorus. Try to fit it at the bottom here. Okay, so then if we solve for P, we get that phosphorus has an oxidation number of +5. Okay, so if we look at the junior tutors examples, KCl, the oxidation number of chlorine is, I think this is supposed to be -1, and the next one it's supposed to be 0. Yeah, I'm going to just say that the rules of calculating oxidation numbers are correct. However, some of the examples given are incorrect. But all in all, I'll just say that this solution is correct. Okay, so question number 4 asks, what is the molar mass of benzene? Okay, so if you don't know the formula for benzene or even its structure, then I'm going to draw it out. Basically, it is a 6-membered ring that is composed of only carbons and hydrogens. And what makes benzene so interesting is that it is aromatic. And it is an overall nonpolar molecule. Okay, so when you have double bonds for every other carbon in a structure like this means that the molecule is aromatic. So for benzene, if we count out all the carbons, there are 6 carbons altogether, and there are also only 6 hydrogens. So to calculate its molar mass, we need to know the atomic masses of both carbon and hydrogen and multiply each value by 6, since there are 6 of each atom. Okay, so if we go to our periodic table and look at the atomic weight of carbon, you'll see that its value is 12.01 grams per mole. And if we were to do the same thing for hydrogen, its atomic weight is 1.01 grams per mole. So if we add these values up, we end up getting a molar mass for benzene, which is 78.11 grams per mole. Okay, so let's see what our junior tutor said. Molar mass, mm, is the mass in grams or kilograms of 1 mole of a unit. Example, atom or molecule of a substance. Since the substance given to us is a molecule, the molar mass of the molecule is the sum of the molar masses of the atoms in the molecule. Formula for benzene is C6H6. Molar masses of the individual atoms are 1.008 and 12.01 grams per mole for hydrogen and carbon, respectively. Okay, so now they just show out their work and also got 78.108 grams per mole. Okay, so I can verify that this solution is correct. Okay, so moving on to question number 5. It is another molar mass question. What is the molar mass of sodium carbonate? Okay, so sodium carbonate is an example of a polyatomic ion. I'll draw out its structure just to show what it kind of would look like. Okay, so to calculate the molar mass of sodium carbonate, we would first need to find out the molar masses of each individual element, and then I'm going to multiply by how many atoms there are of each element. So for sodium, I'm going to do 2 times the molar mass of sodium plus the molar mass of carbon plus 3 times the molar mass of oxygen. So again, these are just values that you would just find on your periodic table. For sodium, its atomic mass is 22.99 grams per mole. For carbon, it is 12.01 grams per mole. And lastly, for oxygen, it is 3 times 15.99 grams per mole. Okay, so now I can add all these values up, and I end up with a final molar mass of sodium carbonate to be 105.99 grams per mole. Okay, so let's see what our junior tutor said. In calculating the molar mass of a compound molecule, first we get the individual molar mass of each atom present from the periodic table. Then we will multiply that individual molar mass to the number of atoms present in the compound molecule. In this case, we have 2 atoms of sodium, 1 atom of carbon, and 3 atoms of oxygen. Lastly, we sum up the molar masses to arrive with the molar mass of the compound. Okay, so they wrote out each individual molar mass for each element, and then they added it all up and ended up also getting 105.99 grams per mole. So this solution is correct. Okay, so moving on to question number 6. What are the properties of matter? Okay, so there are two main types of properties of matter. You could have physical properties. I'll just make like a comparison table. And there are also chemical properties. Okay, so I'll write out the definition of each one. So physical properties are observable, and measurable. There shouldn't be an E here. Measurable. And they don't change. When composition changes. So some examples of physical properties include like density or color, hardness, boiling point, and melting point. Okay, so chemical properties, on the other hand, they become evident during or after a chemical reaction. Okay, so some examples of chemical properties are like its flammability, heat of combustion, toxicity, and radioactivity. Okay, so let's see what our junior tutor wrote. Matter may be classified based on their properties. Properties are characteristics of matter that are either physical or chemical. Physical properties are characteristics that are either observable or measurable without changing the composition of the material. Examples of physical properties are density, color, I'm guessing that is odor, hardness, and volume. Chemical properties are those that characteristics that describe the ability of a substance to change into a new substance. Examples of chemical properties include flammability, toxicity, acidity, reactivity, and combustibility. Okay, so this solution is correct. Okay, so question number 7 just asks, explain the meaning of the inner transition series. Okay, so these are known as like the inner transition metals. So basically on the periodic table, you can find them in the bottom 2 rows. And these 2 rows are also known as lanthanides, and actinides. Okay, so these inner transition metals are also not commonly like used in the industry or like in a lab. And some of them are also synthetic. So some of them haven't been discovered yet, like in the environment. Okay, so let's see what the junior tutor said. The inner transition metals, which are the F block of the periodic table, are the elements found in the bottom of the periodic table of elements. Below is an image reference to see these elements. So here they clearly outlined which are the inner transition metals. These groups of elements are actually the continuity of the transition metals, which is present in the D block of the periodic table of elements. So they can be like inserted like in the middle almost. So their main difference with the D block elements is their electron filled up third shell. They also have variable valencies, with most of them are radioactive. The later part of this group doesn't naturally exist in nature, meaning that they are synthetic elements. Okay, so this solution is correct. Okay, so moving on to question 8. What is the molecular formula of vinegar? Okay, so vinegar can also go by acetic acid, and it can also go by ethanoic acid. In the case of ethanoic acid, it can help us identify what kind of structure vinegar has. So the fact that it has a prefix of eth means that its parent chain will contain 2 carbons. And also the fact that it ends in oic acid means that it also contains a carboxylic acid. So now that we know these 2 things about ethanoic acid, I'm going to draw out the 2 carbon chain, and then I'm also going to show that it contains a carboxylic acid group. And then since carbon needs 3 bonds, or 4 bonds, sorry, I drew out 3 bonds to hydrogen and the other carbon. Okay, so this is the structure of acetic acid. And to write out its molecular formula, it can be like written in different ways. But the main way is just to write it as CH3COOH, just so that we can clearly see that there's a carboxylic acid group. Another way to write it out as if it were called acetic acid is to draw it like this. But both formulas would be considered correct. So let's see what our junior tutor said. The vinegar that we usually use in our house is just a solution. It is a mixture of 3% ethanoic acid. Therefore, what we are referring to here is the ethanoic acid, or simply acetic acid. Acetic acid is HC2H3O2, and remember that it came from an anion acetate, which is C2H3O2. In organic chemistry, it is usually labeled as ethanoic acid, which is in the form of CH3COOH. Okay, so this solution is correct. Okay, so now let's try to move on to question number 9. It is asking, what is the molar mass of iron 3 oxide? So iron 3 oxide has formula Fe2O3. So to calculate the molar mass of iron 3 oxide, we need to know the atomic masses of both iron and oxygen. And I'm going to show out that you would need to multiply just depending on how many atoms there are of each element. So in the case of iron, since there are 2 iron atoms, I'll multiply the molar mass of iron by 2 plus 3 times the molar mass of oxygen. Okay, so these are just the values that you would find on your periodic table. In the case of iron, its molecular weight is 55.85 grams per mole. And in the case of oxygen, it's about 15.99 grams per mole. Okay, so now I'm just going to add up these two values together, and you end up getting a total molar mass of 56.1. No, that's not right. It's sorry. $159.7 grams per mole. Okay, so let's see what our junior tutor said. In solving for the molar mass, we must consider the atomic mass of each element and multiply it to the number of atoms present, then combining all the products. For iron 3 oxide, there are 2 atoms of iron with an atomic mass of 55.85 grams per mole, while there are 3 atoms of oxygen with an atomic mass of 16 grams per mole. Computing for the molar mass of iron 3 oxide will result in 55.85 grams per mole times 2 plus 16 grams per mole times 3, which is equal to 159.7 grams per mole. Okay, so I can verify that this Solution is correct. Okay, moving on to question 10. It's another molar mass question. This time it is for potassium hydroxide. So the molar mass of potassium hydroxide, since there is only one atom of potassium, one atom of oxygen, and one atom of hydrogen, I don't need to multiply any of these atomic masses by however many atoms there are, since there's only one of each. Okay, so from the periodic table, I can find that the molar mass of potassium is 39.10 grams per mole. The molar mass of oxygen is around 15.99 grams per mole. And the molar mass of hydrogen is just 1.01 grams per mole. So by adding up all these values, I get a final molar mass of 56.11 grams per mole. So let's see what our junior tutor said. To calculate the gram formula mass, molar mass, of a compound, the molar mass of the elements that make up a compound is multiplied to the number of atoms, then summed up. Molar mass of each element can be found in the periodic table, while the number of atoms for each element is indicated by the subscript. Potassium 39.10, oxygen 16, hydrogen 1.01. Hence, the molar mass of potassium hydroxide is 56.11 grams per mole. Okay, so this solution is correct. Okay, so on to question 11. Simply just asks, what are isotopes? This is an interesting question, but basically, isotopes of an atom would have the same number of protons. So what makes every element unique is that they have a specific, like they have their own number of protons. Like you wouldn't have an element that has the same number of protons as another element. And this is determined by an element's atomic number. So like for hydrogen, for example, there is only one proton, so its atomic number is 1. For helium, there's 2 protons, so its atomic number is 2, and so on and so forth. But in the case of isotopes, they would have the same number of protons, but what makes them different is that they have a different number of neutrons. So neutrons don't have a charge, unlike protons or electrons. Like protons have a plus charge and electrons have a minus charge. But in the case of neutrons, they are neutral. But they also have a significant weight to them. So in the case of like electrons, they're very light compared to protons and neutrons. And the mass of neutrons is pretty much almost the same as the mass of protons. So let's look at what our junior tutor said. It looks like they have a lot of helpful examples. So they said that isotopes are elements with the same number of protons but different number of, I think they meant neutrons. The number of protons indicate an element's atomic number, and adding the number of neutrons and protons result to the mass number. In other words, isotopes are also elements with the same atomic number but different mass number. That's another way of putting it as well. Hydrogen is an example of isotope, as seen in the figure below. They all have the same number of protons but different number of neutrons. So here is a protium. So there is no neutron in protium. There is only the one electron and the one proton. In deuterium, there is one neutron shown, the one electron and the one proton, and you can see that it is heavier than your protium. For tritium, you'll see that there are two neutrons, one proton and one electron, so it's even heavier than deuterium. But these are all different isotopes of hydrogen. So basically the atomic mass that you would find on the periodic table is an average of all of the masses of these isotopes. So that's why some of them are have decimals. It's because it's an average of all the different isotope masses. Okay, so this solution was correct, but I'm also going to copy this part and just correct that part. Different number of neutrons. But literally everything else was correct. But that is a pretty main difference in the solution. I'll just say that this was incorrect for now. Okay, so the next question asks, what is the structure of acetic acid? Okay, so I actually answered a similar question involving ethanoic acid, so let me just go back to that question just so we can help answer it. Yeah, so it's right here. So just to recap, acetic acid can also be known as ethanoic acid. Since it has a prefix of eth, that means its parent chain contains two carbons. And because it ends in oic acid, that means it contains a carboxylic acid group. So here I drew out the structure of acetic acid and also its chemical formula. Okay, so let's see what the junior tutor said. Acetic acid is an organic compound with a chemical formula CH3COOH. Its IUPAC name is ethanoic acid. It is a colorless liquid, which is also the major component of vinegar. Vinegar is mostly 4 to 6% acetic acid. Let me just edit my number. So this is question number 8/number 12. Anyways, the structure of acetic acid is illustrated below. So they show that its parent chain has the two carbons. One of the carbons has the carboxylic acid functional group, and the other one just contains the remaining hydrogens. It is a carboxylic acid consisting of a methyl group that is attached to a carboxyl functional group. In a solid state acetic acid, there is a chain of molecules that are interconnected with hydrogen bonds. And also in its vapor state phase, dimers of ethanoic acid can be found at a temperature of 120 degrees Celsius. These dimers can also occur in the liquid phase in a dilute solution of non-hydrogen bonding solvents. Okay, so this solution is correct. They also added some additional points, which is also useful. Okay, so now we are on to question 13. What is the molar mass of nitrogen? So if we're just looking at atomic nitrogen, you can just find this on your periodic table. It is 14.01 grams per mole. But if we were to look at the diatomic nitrogen gas, which is N2, it's simply 2 times the molar mass of nitrogen. So for nitrogen gas, 2 times 14.01 is equal to 28.02 grams per mole. Okay, so let's see what our junior tutor said. The molar mass of an atom can be simply found in the periodic table of elements. The unit of the mass is U, which is also equal to grams per mole. The molar mass of nitrogen up to 6 significant figures, well, is 14.0067 grams per mole. Okay, so I can verify that this solution is correct. Okay, on to question 14. What are the 5 types of chemical reactions? So this is a good question. Let me just have a little title. So there are 5 main types. Let me make them in different colors. One of the main ones would be considered like a combination reaction. So this is when you would have, let's say, element A plus element B come together to form element AB. Okay, so this is the simplest combination reaction that you could have. The second type of chemical reaction would be decomposition reaction. So this is, you can think of it as the opposite of a combination reaction. This is when you start off with a compound, AB, and its products are the elements coming apart to form A plus B. You could have a single displacement reaction. So it can also go by replacement. Displacement slash replacement reaction. So this is when you would have at least 3 elements involved. So let's say you had A, B plus C. Basically, the C would swap out with one of the elements, and you end up getting AC plus B. So similarly, there's also something called a double displacement reaction. So as you can guess, it is similar to single displacement, except this time there are 4 elements that are involved. So let's say we had AB plus CD. When you have a double displacement reaction, then 2 elements will switch places with the other 2, if that makes sense. So instead of AB, it got switched up and made AD plus BC. So you can imagine like the intermediate of this reaction to just be all of the ions like separated and then coming together with the opposite element. And the last type of chemical reaction is just simply called a combustion reaction. So combustion reactions are pretty easy to identify. That's because they always have like a hydrocarbon group. It doesn't matter the type, so I'm just going to say like X and Y. And this hydrocarbon is exposed to oxygen. So oxygen would be one of the reactants. And the products will always form carbon dioxide and water. So depending on which hydrocarbon you start at, you would need to balance out however many carbon dioxides and however many waters to balance out all the carbons and hydrogens in the equation. Okay, so these are the 5 types of chemical reactions. Let's see what the junior tutor said. Types of chemical reactions are as follows. Combination slash synthesis. A plus B makes AB. Decomposition. AB makes A plus B. Single displacement. AB plus C makes AC plus B. Double displacement is AB plus CD makes AD plus BC. And lastly, combustion, CH plus O2 makes carbon dioxide plus water. Okay, so this solution is correct. Okay, so moving on to question 15. What is the molar mass of copper 1 nitrate? I think they meant copper 2 nitrate. But anyways, they give us the chemical formula regardless. And in order to calculate the molar mass of this compound, we need to determine the molar masses of each individual atom. Okay, so these are just the values you would find on your periodic table. And I'm also going to take into account how many of each atom are in the compound. So in the case of nitrogen, there's 2. So I'm going to multiply the molar mass of nitrogen by 2. And I'm also going to multiply the molar mass of oxygen by 6. Okay, so if we pull out a periodic table, you'll find that the atomic weight of copper is 63.55 grams per mole. The atomic mass of nitrogen is around 14.01 grams per mole. And the molar mass of oxygen is 15.99 grams per mole. Okay, so adding up all of these different values, you get a final molar mass of 187.57 grams per mole for copper nitrate. Okay, so let's see what the junior tutor said. To calculate the gram formula mass or molar mass of a compound, the molar mass of the elements that make up a compound is multiplied to the number of atoms, then summed up. The molar mass of each element can be found in the periodic table, atomic mass, while the number of atoms for each element is indicated by the subscript. So in the case of oxygen, there's a subscript of 3, but for the nitrate ion in general, the whole thing is a subscript of 2. Okay, so then they said, based on the chemical formula, there's 1 copper atom, 2 nitrogen atoms, and 6 oxygen atoms in the compound. Hence, its molar mass is 63.55 times 1, 14.01 times 2, and 16 times 6 gives 96. They added up all the values and got 187.57 grams per mole. Okay, so this solution is correct. Okay, so I think we have time for one more question. What are the chemical properties of matter? Okay, so just to recap, there are 2 main types of properties of matter. So you could have physical, which is observable and measurable. And it doesn't change. When composition changes. Or you could have chemical properties. So these properties become evident during or after a chemical reaction. Okay, so let's see what the junior tutor said. Chemical property is a property of matter that is associated with chemical change. Chemical change takes place when there is breaking or forming of new chemical bonds. Some examples of chemical properties include the ability to oxidize. So oxidation is the loss of electrons from an atom, It is a chemical property because a change in the oxidation number of a substance occurs. Flammability describes how easily a substance might ignite or burn. It is a chemical property because burning involves a change in the chemical composition of a substance. Heat of combustion describes how much energy is released when a substance undergoes combustion. It involves the reaction of a substance with oxygen, which alters the composition of the substance and releases heat as a result. Radioactivity is when atoms with unstable nuclei emit radiation to become stable. This causes changes in the number of subatomic particles such as electrons, neutrons, and protons. Lastly, toxicity. This describes how much damage to a living organism is caused by a substance. It is a chemical property because the substance can react with the cell and or its components. Okay, so that was a great explanation. And this solution is correct. Okay, so that is all for today's Q&A session. And if you liked today's session and you'd like to be notified of when we do this next, then please hit the subscribe button and notification bell below. If you'd like to submit a question of your own, then check out the links in the description. And also, if you liked today's video, don't forget to leave it a like and a comment. And also, share it with all your friends and classmates if they needed any help with chemistry. This has been Donna from OneClass, and I hope to see you soon.